Okay, this is going to be part one of the section 4.2 notes, and those notes start on page 112. Okay, first of all, we're going to talk about something called the zero product property. Now, you know the concept, you just don't know it, as having a formal name. So the zero product property says if you multiply two numbers, so a times b, and if you know the answer is zero, then that means either the first number is zero or the second number is zero, right? Because when you multiply by zero, it equals zero. But keep in mind, that's only true when we say it equals zero. So look at my true-false question. If you multiply two numbers, say a times b, and you know the answer is 10, can you say the same thing as we did above? Can you say that that means either the first number is 10 or the second number is 10? No, of course not. It's only true if it's equal to zero. So that's a big false. Which you may think, okay, well, why are you even talking about this? Well, because later on when we get into some solving, you'll notice people are going to try and say it's true for other numbers, and it's just not. Okay, so that brings us to, now that we know how to factor, we're going to talk about how to solve equations by factoring. Okay, so anytime you have a quadratic equation, I'm going to write that down, quadratic equation. And basically a quadratic equation just means that there's an x squared in the equation somewhere. Okay, so quadratic means there's x squareds involved. And I say x, it could be any variable. Okay, so in order to solve by factoring, the first thing you have to do is, this is key, you have to set the whole equation equal to zero. So when I look at letter A, notice I have x squared minus 5x plus 6, and it's already set equal to 0. So that's already done. But like if I'm going to solve for b, I can't solve by factoring because this whole thing is not set equal to 0. So the first thing I'm going to have to do is subtract that 26p. So I've got the 4p squared, and when I subtract the 26p, I'm going to go ahead and put it right here in the middle, and then I still have the plus 40. And now I've set equal to 0. Notice I put it in the middle because don't we normally see the squared term and then the single term and then the constant? Okay, so first thing you always have to do is set equal to 0. Once you have it set equal to 0, you factor. So if I were to factor this, first of all, 4, 26, and 40, couldn't I take out a common factor of 2? So remember, we always look for a common factor first. All right, so let's take out a common factor of 2. It's going to leave me with 2p squared minus 13p plus 20. Okay, and even when you find a common factor, you need to go on and see if you can factor that parenthesis. So I'm going to leave that 2 out in front. So can I turn this into trial and error? Well, I know my signs are the same of minus. I know I have to multiply to get 2p squared, so it's got to be 2p times p. And I know I have to multiply to get 20. So if I'm going to use 4 and 5, I'm going to have to put the 5 here and the 4 here. Okay, so I need to check. Remember, in order to check your trial and error, you have to do the outer and the inner. So let's see, the outer is going to be negative 8. And the inner is negative 5p. That definitely gives me negative 13, so I know it's going to work. Okay, so here comes what makes this different than what we did the other day. So far I've factored. But if I'm going to solve, and you did this back in Algebra 1, so hopefully you kind of remember doing this in Algebra 1. If I'm going to solve, I know that in order for these three numbers to multiply and equal 0, any particular factor has to equal 0. Well, I don't have to worry about this 2 out in front because 2 is never going to be 0. But what about the next factor? It might be that 2p minus 5 equals 0. Or it might be that that other parenthesis, p minus 4 equals 0. So remember, when you solve by factoring, after you have it factored, you have to set each individual factor equal to 0. And then solve each one of those. So if I look at my first one, if I'm going to solve for p, wouldn't I add 5 and then divide by 2? So p could be 5 halves. Or if I take this second one, if I solve for p, wouldn't I have to add 4? So p would be positive 4. Okay, so when you solve quadratics, you're likely going to have two solutions. Okay, so let's go back to letter A. Remember we said, first thing, make sure it's set equal to 0. Done. But then we said we're going to factor. So if I factor this side, I know I'm going to have the same of minus, right? I know it has to be x times x. And then in order to get 6, I'm going to go 3 and 2. Does that work? Does that give me the negative 5? Yeah, it does. It gives me negative 5x. So I set each individual factor equal to 0. So if this one equals 0, then doesn't that mean x equals 3? But if this factor is the one that equals 0, that means x could equal 2. So I have two solutions. Okay, look down at letter C. All right, when you first look at letter C, first thing is it set equal to 0? Yes, so that's good. Next thing, can we factor? Well, do you notice it's a difference of squares? So if it's a difference of squares, remember, automatically you know you have a plus and a minus. To get 16m, that's going to be 4m times 4m. And then to get the minus 25, wouldn't that be a 5 times 5? So I did my difference of squares. Remember, on difference of squares, you don't really have to check it. And so now set each factor equal to 0. And let me give you a little kind of handy-dandy shortcut. If I want, I could write this whole thing out, and I will on the first one. I could say, okay, what if 4m plus 5 equals 0? Then you would subtract your 5, right? That's going to make it be negative 5. Then you would divide by 4, so m equals negative 5/4. But compare your answer to the original parenthesis. Do you see that it came out to be the opposite sign, second number over first? So if I apply that shortcut to this one, m equals opposite sign, so positive, second number is 5 over the first. Okay, so there's that one. Take a look at letter D, and you may notice it's missing the equal sign. Okay, so this should have an equal 0. Sorry about that. That should be on there. All right, so step 1, set equal to 0, done. Step 2, can you factor it? Well, what if we factor out an x squared as a common factor? That'll leave me with 6x minus 1. Okay, and so remember we said you set each factor equal to 0, so we could do the shortcut on this parenthesis. Remember the shortcut, it's always going to be the opposite sign, so it's positive. Second number over first, so 1 over 6. So there's one possible solution. And look at this. If you set this one equal to 0, right, x squared equals 0, how would you solve for x? Well, wouldn't you just take the square root of both sides? But what is the square root of 0? Isn't it just 0? So anytime you have a common factor that has an x in it, you know you're just going to have a solution of 0. Okay? So that's the first part of section 4.2, the solve by factoring. And the part of the homework that corresponds to those examples would be the first page on page 114, the number 1 through 8. So 1 through 8 of the homework correspond to the examples that we just did.